inverse functions. Two functions are inverses if they undo each other. So, in other words, if we had, for example, 3, and we added 5 to that, we get 8. So just an easy example. So what do we do to 8 to end up with 3? Well, we would subtract 5. So x plus 5 and x minus 5 are inverses of each other, because if we do one and then put our answer in and do the other one, we would get what we started off with. We end up with what we started off with. So those are inverses of each other. The notation for an inverse is f to the negative 1 of x. That's our notation that means it's an inverse function. Okay, and we just say this is an inverse of x. Now, for us right now, we are going to be doing one of two things. We are either going to be given a function and find its inverse, given a function and find its inverse, or we will be given two functions and decide if they are inverses of each other. So we are either going to be given a function and have to find its inverse, or we're going to be given two functions and just have to decide if they are inverses of each other. Okay, so the first thing that we want to do is to find the inverse of a given function. So we're given a function and we want to find its inverse. Well, in order to do that, first, replace f of x with y. Replace f of x with y. Then interchange x and y. And then solve for y. If the new equation does not define y as a function of x, then there is not an inverse. And then 4, replace y with the notation for an inverse, which is f to the negative 1 of x. And verify. And we'll learn in just a minute how to verify them. Okay, but you always can check these, just like you can check an equation, you can check these to make sure that you're correct. And some of these are going to be really easy, and then some of them get a little more difficult. But, so let's say we want to find the inverse of f of x equals 3 over x minus 1. F of x equals 3 over x minus 1. Well, the first step was to rewrite it and use a y here instead of f of x. And we just simply do that because it's easier to deal with a y than to rewrite that f of x over and over. So now we've got it with y. Then, that was the first step. Second step is to interchange x and y. Interchange x and y. So that means this becomes x and our x becomes y. So we've changed them around. Then we're going to solve for y. Well, to solve for y, I'm going to add 1. So x plus 1 equals 3 over y. Then to get y off of the bottom, I'm going to multiply by y so that it'll cancel. So that means I have to multiply this side by y. So I get y times x plus 1 equals 3. Then I have to divide by x plus 1 to get that y by itself. So y equals 3 over x plus 1. And then the last step is to rewrite y as f negative 1x equals 3 over x plus 1. Okay, so this was what we started off with, and our inverse is 3 over x plus 1. Now, to verify, we have to do something a little more exact mathematical than what I'm getting ready to show you. But what I want to show you is just an example of what has happened here. So f of x equals 3x minus 1. So let's take something that's going to be easy. Let's let x equals 6. If x equals 6, f of x would be 3 over 6 minus 1, which is 1/2 minus 1. That's negative 1/2. So then the inverse of negative 1/2, if I put that into my inverse function, I would have 3 over negative 1/2 plus 1, which is 3 over 1/2. 3 divided by 1/2 means that I'm going to do 3 times 2 over 1, which is 6. So as you can see, our x originally was 6, and then when we put that 6 into our original function, and then we put that answer into our inverse function, we end up with what we started off with. So that's what an inverse does. Now this is not how we verify, not how we algebraically verify. But I just want you to see that numerically that's what's going on. Okay? Now, algebraically though, in order to verify, we prove that two functions are inverses of each other. Well, in order to do that, the actual definition says that if f of x and g of x are inverses of each other, then f of g of x will equal x, and g of f of x will equal x. So if I'm going to use the one that we just did, let's verify that f of x equals 3 over x minus 1, and 3 over x plus 1 are inverses of each other. Okay, that they are inverses of each other. So, if I take, first of all, we want to find f of the inverse, and then we're going to find the inverse of the original. Now, if both of those equal x, then they're inverses of each other. So for the first one, we're going to take this function and put it in here for x. So we're going to do 3 over x plus 1 minus 1. Okay, now this gets a little tricky algebraically, but right here, to get rid of this x plus 1, we want to multiply this fraction by x plus 1 over x plus 1. See that? So this gives us 3 times x plus 1 over, those cancel, 3 minus 1. Now remember, we're supposed to end up with only x, so a bunch of stuff ends up canceling out pretty soon. So here the 3's cancel, and I'm left with x plus 1 minus 1, and that equals x. So we're good there. Okay, so look at that again. We started off with this 3 over x plus 1 minus 1, because we took this function and replaced the x with all of this one. Then we multiplied by x plus 1 over x plus 1 and let these cancel, and that leaves us just a 3 on the bottom and 3 times x plus 1 on the top minus 1. 3's cancel, you have x plus 1 minus 1 plus 1 minus 1 cancels, and you have x. So that one's good. So now let's try it with the other way. So the other way, we're going to take this whole function and put it over here for x. So now we've got 3 over x minus 1 plus 1. So originally, the inverse is 3 over x plus 1, and we're replacing x right here. All of this is the x here. We're replacing it with this function. Okay, then we're going to do our simplifying. So down here we've got a minus 1 plus 1, which cancels out each other, and you get 3 over x. Remember, when we multiply, a lot of you still do what your, I guess, middle school teachers taught you of keep, change, flip. So this is 3 divided by 3 over x, so we're going to keep the 3, change it to multiplication, and flip 3 over x to x over 3. 3's cancel, and you're left with just x. So both of those work. Okay, so mathematically here, negative 1 plus 1 canceled each other out. So that left us with 3 over x. This is 3 divided by 3 over x. So to divide fractions, we change it to multiplication and flip the second one. So it's going to flip to x over 3. Our 3's cancel, and we just have x. So since both of these ended up being x, then we know that these are correct, that they are inverses of each other. Okay? Now, this is just one example of each. So try these out. You have more examples in your book. Some of them get a little more complicated, and we have some more examples that we'll do in class. But remember, if you want to get rid of a root, if you've got a radical, remember that in order to get rid of the cube root of x, if you want to get rid of that cube root on there, you have to take that to the third power and you get just x. Or if you have x to the, let's say, 1/4 power, then you would have to take that to the 4th power and you would have just x. So remember, those are always the trickiest part of this section, I guess, is where you have those radicals. Okay, so we'll go over questions in class, read the examples in your book, and you can see also graphs of how inverses work. And this is going to fold and glue to page, oh, I don't have it on here, but I don't remember. We'll look at it in class. We'll make sure we get it glued to the right place. And it should be on your list. So have a great day.